Let's talk about Project 2, Lesson 7, Question 1. An auto race consists of 8 laps. A driver completes the first 3 laps at an average speed of 185 miles per hour, and the remaining laps at an average speed of 200 miles per hour. If D represents the length of one lap, which expression represents the time in hours, T, that it takes the driver to complete the race? And then you're given multiple choices to select from. So think back to this equation we've been using for the past few questions, which is distance equals rate times time. How can we use this equation to help us answer this question? Well, first of all, we're told that there are 8 laps here, and that D represents the length of one lap. We don't know any times, right? But we do know 2 different rates that are happening. At one point, the average rate is 185 miles an hour. At another point, 200 miles per hour. So now, considering that our goal is to select the expression that represents the time in hours T that it takes the driver to complete the race, how can we put all this information together to get our solution? Well, first of all, since our goal is to have an answer in terms of T, it might help us to rearrange this equation in terms of T as well. So if I want to solve for T, I'm going to divide both sides of the equation by R. That gives me that time is equal to distance divided by rate. Time is equal to distance divided by rate. Now let's consider the first set of numbers we're presented with, which is that of the total of 8 laps, the driver completes the first 3 laps at an average speed of 185 miles an hour. So if I was computing the time for the first 3 laps, it would be easy for me to say, okay, the time for the first 3 laps is equal to 3D over 185. Now, why did I write 3D? Well, remember that D is only equal to 1 lap. So I have to multiply D by the number of laps I'm talking about. So since this is the time for 3 laps, I have 3D as my numerator and 185, the rate, as my denominator. Next, I would consider the time it took for the other 5 laps. So it says the remaining laps were taken at an average speed of 200 miles per hour. So if I wanted to calculate the time for the 5 remaining laps, my numerator would be 5D, because D equals 1 lap, so 5D equals 5 laps, divided by 200, which is my rate. So notice that I've now set up these 2 different pieces. These are 2 individual equations, one for the time that it would take for 3 laps, another the time for 5 laps. From here, you have to figure out a way to combine the information in front of you to figure out what the equation would look like for the total time for all 8 laps. So how will you use this to find the time for all 8? Question 2. The driver's average speed to complete all 8 laps is blank miles per hour, round to the nearest tenth of a mile per hour. So remember that to find an average, you add up all the numbers you have and you divide by the number that you have in front of you. And also remember, we were told that the first 3 laps were at 185 miles an hour and the last 5 laps were at 200 miles an hour. So I'll warn you now that it is not correct simply to take the average of 185 and 200 and divide by 2 and find the average of these 2, because he spent more time traveling at 200 miles per hour than he did at 185. So it would be reasonable that whatever answer we get will be a little bit closer to 200 miles per hour than it will be to 185. So again, think about what it means to be an average and consider that he spent more time going the faster speed, and you take it from here to find your solution. Finally, question 3, we're asked to refer to the table of results of the Indy 500 in which drivers competed in the 500-mile race. To the nearest mile per hour, how much faster was the average winning speed in 2004 than in 1911. So let's think about what we're being asked to do. The question is, how much faster was the average winning speed in 2004 than in 1911? So we know we're going to be doing a comparison. So our final equation should look like the speed in 2004 minus the speed in 1911, and that will give us the difference. So it looks like in order to do this, we're going to have to calculate first the speed in 2004, and then we'll have to calculate the speed in 1911. Now remember that we're using our distance equals rate times time equation. In this case, since we're asked to solve for speed, we need to manipulate the equation and solve for rate. So rate is equal to distance over time. Find rate for both years and then find the distance between the two to find how much faster the average winning speed was in 2004 than in 1911.